Within Step 7, we have a tool that lets us look at reference data to do things like look at I/O cross-referencing, look at where particular inputs and outputs have or have not been used, and also look at the structure of how the blocks in the program call one another. To use that, we click on the blocks folder within a project, and in this case we're using an example program that comes as part of Step 7. It just has several blocks in it, so it's a good example to use. If we go to Options, Reference Data, and click on Display, we'll get an information block coming up saying that filtered data will be displayed. We don't, by default, get every address type that there is. We can pick and choose, and we can say we want to see cross-reference as the first view that comes up. Now here in the cross-reference overview, we have different columns for the input addresses. We have output addresses there, memory words, and the timers. Another column gives us the symbolic names that go with those I/O points. And then a column that shows the blocks where that particular element's been used. And if we resize the column, we see R's and W's for reads and writes, whether that particular element's been used as an input or as an output within the program. And here we actually have some Q's that are being used back as inputs on contacts there. The LAD shows that all the blocks and all the elements have been used in ladder logic. And details show the network numbers or the rung numbers where that particular element's been used and how it's been used. ANDs, ORs, outputs with the equals, set, reset, and not, or as part of a call to another program block. So it pretty well gives us a lot of detail there. We can click on a particular output like Q5.0, then right-click on there and say, give me a cross-reference for that specific address, and kind of filter things down again. Here we see that Q5.0 has been used twice in OB1, Organization Block 1, and get our column sized up. We'll see it was used as a write and as a read both. At Network 4, it was part of a call to a block, and at Network 6, it was used as an AND contact. Okay. If we right-click on one of these elements, we can say go to that location specifically and bring up OB1 on the network where that particular point is being used in that instance. So it was in Network 6, and down here we see it was used as an input coming into this box, Q5.0, with its symbolic name and its comment. We can turn off and close the ladder editor, go back and look at the other instance where Q5.0 is used. Say go to that location with a right click. And we're back in the ladder editor in OB1, this time at Network 4, and it was listed as part of a call. So here we have a call to function block 1, and there is Q5.0 with its symbol name and its comment listed right there as part of that block call. It's a return value that was calculated by FB1. Okay, we can close the ladder editor again and close the view here where we had just gotten our specific element cross-reference. And also we can go back and show, if we right-click back in the overview, we can also go straight to that location. So there's several different ways of getting into the block where that element's been used. We have some buttons on the toolbar up here that let us look at this reference data in different ways. This opens up an I/O list that shows which points have and have not been used. Here we see I0.1, 0.2, 0.3, 0.4 through 6 have all been used. I0.0 and 0.7 have not been used, with a little dash indicator shows that. Input 1.3 has not been used, and input 1.7 has not been used. And none of these that have the dashes have been used in the program anywhere. Down at memory locations, we see MB2, and over in the columns that are marked byte word or double word, we have an O there in the word column. That means we're going to use 16 bits to make a word, starting with memory byte 2. Also, another word coming in here at memory byte 4. So it's memory word 4 using memory byte 4 and 5. Then we open up our timer counter view. We see that we use timer number 1 and number 2. And then we have dashes everywhere else showing that none of those other timers or any of the counters have been used at this point. Then we can look at the program structure. This really simplifies showing how the different blocks are calling one another. Within the program, we have OB1, our main program. Then that OB calls function block 1 using data block 1. Then it calls function block 1 again using data block 2, passing different information. And then we also call function 1, FC1, twice from 2 different locations in OB1. And we also see that we use DB3, data block 3, for general data information in the program. If we want to go look at one of these blocks, we can click on FC1 in this case, and it takes us into the ladder editor showing that we have a 4-second off delay timer as that function. And all it's doing is giving us an off delay on the fan control. If we want to look at FB1, we can get the same place by right-clicking and saying Go to block, just like we double-clicked before. This time we're just using a different method to open the block. And here we see we just have some logic control, doing a set reset, and we also monitor the speed using a comparison down there. The unused symbol button shows us any symbolic names that we defined in our symbol table but weren't used in the program. And I just went in and put this one in so we'd have one to see. But it's a way to check and make sure that if you defined it as a symbol, you did use it in the program and didn't forget. And also, addresses without symbols, I put in an input in the program at I12.0 and did not give it a symbolic name. So this is showing me, okay, I have a address that I've used, but I forgot to give it a symbol. We'll go back to our cross-reference now and look at what we can do with filtering. I mentioned earlier, we don't necessarily see everything. By default, we see inputs, outputs, bit memory, the M's, counters and timers, and any of their address ranges. If we want to see data block information, we can click there. And then we also have a filter area where you can go in and specify ranges or specific inputs or outputs that you want to see. And you can also select either all or only looking at reads or just write locations. And you can save that as a standard if you want to and click OK. And now we get the same overview again, but now we've added data blocks to our mix. So we see data block 1 and 2 being used in OB1. Go back to our filtering, and if we go to program structure, we can see we can filter some of that as well. We saw all blocks, but if we just wanted to see function, starting with function 1 and anything that it called, we could start there and just see the chain of calls from that. Again, if you want to have that be your standard that always comes up, click that checkbox, say OK, and we're back to our main overview. We can close our reference data now and put us back into Semantic Manager.